In this lesson, we are going to discuss rationalizing the denominator. This is located in section 7.2 on page 573 in your text. We are going to work numbers 48 through 70 even. Then we are going to move to the end of section 7.3 where there are more problems on rationalizing the denominator. So in the directions, they state to simplify each expression. Assume all variables represent positive real numbers. So we learned in the beginning of section 7.2, in order to simplify, we are going to make a tree out of this 8. It's called a prime factorization tree. And we break the 8 up to be two numbers multiplied by each other to get 8. So two numbers that multiply by each other are going to be 2 and 4. Every time we see a prime number, we're supposed to circle it. And then we break the 4 down to be 2 and 2. Then we rewrite our expression to have our 2's multiplied by each other. And this hidden number right here that we don't know what it is, it's understood there is a 2 there. That is called our index. The index tells us how many of a number we need to release it from the radical. So since we have 2 2's, they're going to be released as 1 2. And then this 2 here is going to stay inside the radical because it did not have another one to make it a pair. Now the issue here is that we have a radical in the denominator. The whole goal is to get the radical out of the denominator. So we have to think to ourselves, what can we do to release this 2 from the radical? It's what we just discussed, and we would have to multiply that square root of 2 by another square root of 2. By doing that, that would give us the pair of 2's we need to release it from the radical. Remember, the only issue is that there is a radical in the denominator. We can have a radical in the numerator all day long. The reason we didn't break the 5 apart up here is because it is a prime number. Prime numbers cannot be broken down or simplified. So when we multiply the denominator by square root of 2, by the fundamental principle of fractions, we have to also multiply the numerator by the square root of 2. So we are going to multiply 5 times 2, which will give us the square root of 10. Remember, we can multiply the 5 times 2 because they are both under the radical. Then in our denominator, we are going to multiply these two 2's together. The reason we do not multiply it by this 2 on the outside is because it is not under the radical. So that would leave us the 2 here from this 2. And then the square root of 2 times the square root of 2 will give us the square root of 4, which the square root of 4 is 2. So we bring this 2 over, and then the square root of 4 is 2 here. Now we are going to multiply these 2's together because whenever you have a 2 next to a radical, that operation means multiplication. Just as if it was a 2x as demonstrated here. If you have a 2 next to an x, that also means multiplication. Same rule applies with radicals. So that would give us the square root of 10 over 4 because 2 times 2 gives us 4. We cannot simplify the square root of 10 and the 4 because the 10 is under the radical and the 4 is not. You can only simplify these if both numbers are outside of the radical. So this would be our final answer. Now we are going to move on to number 50 on page 573. Number 50 says I have the square root of 5 over the square root of 11. Now remember, the whole goal is to get that radical out of the denominator. 11 is called a prime number, so we cannot break it down as we did up here with the square root of 8. We can't break it down first. So what I'm going to do is multiply the square root of 11 by the square root of 11. Remember, what you do to the denominator, you must do to the numerator. By doing so, that will give us the square root of 55, because 5 times 11 gives us 55, and we can do that because they're both under the radical, over the square root of 121, and we get that by doing 11 times 11. Then 55 does not break down, because if we look at the two numbers we multiplied to get 55, were 5 and 11, which are both prime numbers. So there's nothing that we can break these down to be, so we have 2 to release it. Over 11, because the square root of 121 is 11. Again, we cannot simplify that 55 and 11 because the 55 is under the radical. We are now finished because we have met our goal by getting the radical out of the denominator. Now we're going to look at number 52. Number 52 says 3 onto the square root of 5 over the square root of 3. So we're going to multiply by the square root of 3 because we have 1 3 and we need 2 of them to release it from the radical per our index right here. So we multiply by another 3. So in my numerator, that gives me 3 onto the square root of 15 over the square root of 9. We got 3 onto the square root of 15 because 5 times 3 is 15, and the 3 stays on the outside. And because 3 times 3 is 9, that's how we got the square root of 9. Now I'm going to go ahead and break down my square root of 9, which is 3, because 3 times 3 is 9. Now, if I were to give you the problem 3x divided by 3, you would tell me that we could simplify these 3's because they are being multiplied by that x, and 3 goes into 3 once, 3 goes into 3 once, leaving us with just x. So this is the same concept. You can simplify those 3's because they are outside of the radical. So the number that goes into both of those is 3. So I'm going to divide this number by 3, which gives me 1. This number by 3, which gives me 1. So my final answer will be the square root of 15. Remember, some people may be tempted to leave it as the square root of 15 over 1. That is not simplified. Remember, the directions say to simplify the expression. Simplified, if it has a 1 in the denominator, that means it is not all the way simplified. Now we are going to move to number 54. Number 54 says the cubed root of 5 over 9. This problem looks a little different than what we're used to. What we're going to do here is we're going to break up that cubed root of 5 over 9 to be the cubed root of 5 over the cubed root of 9. Remember, we need to break this apart, if we can, to see what we have. Because once we know what we have, we can find out what we need. I'm going to use some different colors to demonstrate this. So if I have the cubed root of 9, that is like saying I have the cubed root of 3 times 3, because 3 times 3 gives me 9. Now remember, this number here is my index. That tells me how many of a number I need to release it from the radical. So if I have 2 3's, I will need one additional 3 to release it from the radical. Okay? So I'm going to multiply the denominator in this case by the cubed root of 3. So that will give me the cubed root of 15 over the cubed root of 27. I will then have the cubed root of 15 over 3. I get that because the cubed root of 27, meaning the number times itself 3 times, is 3. Okay? So we cannot simplify the 3 and the 15 because the 15 is under the radical and the 3 is not. Remember, they both have to be outside of the radical in order to simplify them. And the real big thing here is to remember that it is the cubed root, meaning do not forget that index. If you were to forget that index, that would make your answer wrong. Okay, so next we're going to move on to number 56. They're going to add some variables in here for us in this problem. So on number 56, I have the square root of 3 over x. Remember, we can break this apart to be the square root of 3 over the square root of x. The whole goal is to get the radical out of the denominator. So I am going to multiply by a square root of x on the denominator and on the numerator. That index of 2 reminds us that we need 2 of a number to release it from the radical. So that works for variables as well. So since I have 1x here, I need 1 additional x to release it from the radical. So that would give me the square root of 3x over the square root of x squared, which then gives me the square root of 3x over x. Again, you cannot simplify those x's due to this x being under the radical. This is our final answer. Next, we're going to look at number 58. We have the square root of 18 over a. So 58, I have the square root of 18 over the square root of a. So we can take this problem one of two ways. You can either simplify the 18 first, or you can get rid of the radical in the denominator in the beginning and then simplify that 18. It is whatever you wish to do. Since simplifying the 18 isn't going to change anything when rationalizing, I'm going to go ahead and break down that a. However, when we looked at number 48, it was important for us to go ahead and break down that 8. It made that square root of 8 because it made it a little bit easier. Here it doesn't make a difference because what we can simplify is in the numerator. So let's go ahead and multiply by the square root of a. And we do that in our numerator and our denominator, which will give me the square root of 18a over the square root of a squared. And then 18, we can break that up to be 9 times 2. Remember, this is our prime factorization tree. So whenever we have a prime number, we're going to go ahead and circle those numbers. And then then 9 breaks down to be 3 times 3. So we then have the square root of 2 times 3 times 3, and then we have that a there, over a, because a times a is a squared. So a pair of 3's will come out because we need 2 of a number to release it. So we now have 3 onto the square root of 2a over a. We are now finished. Nothing else will simplify, and we have met our goal by getting the radical out of the denominator. So now we are going to move to number 60. We have the square root of 24x to the 5th over 7y. Again, this is number 60. So we can break this apart to be the square root of 24x to the 5th over the square root of 7y. Remember, you can go ahead and simplify your numerator first. However, since it's not going to change anything when rationalizing the denominator, I'm going to simplify it at the very end. So we have to think about what can we multiply by to get the 7 and the y out of the radical. So if I already have 1 7, that means I need 1 more. And if I already have 1 y, that means I need 1 more y. Next, I'm going to multiply the numerator by the square root of 7y. Whatever you do to the top, you've got to do to the bottom. Same thing. So that's going to give us the square root of 168 x to the 5th y over the square root of 49 y squared. So I can break up 168 very easily because I know that 2 factors that we can use are 24 and 7 because I just multiplied those 2 numbers to get 168. And since that's what I'm breaking down, I know I can go ahead and use those 2 as factors. 7 is a prime number, so I can circle it. 24 will be 6 and 4. As a side note, if you used 8 and 3 or 2 and 12, notice you will get the same exact factors as I'm going to get by using 6 and 4. So that gives me 2 and 3, and then this gives me 2 and 2. So now I'm going to replace my 168 with all of my factors. Remember, these are the prime factors. So I'm going to put them all in numerical order, grouping all the 2's together, the 3's and the 7's. Then I have 5 x's and a y. Remember to extend your radical sign the whole way. It needs to reach after the entire expression. Then for our denominator, I'm going to go ahead and simplify the 49y squared to be 7y. And then a pair of 2's will come out. That's all that we can pull from the numbers. And then we have a 2, a 3, and a 7 left in the inside. So 2 times 3 is going to be 6. 6 times 7 is 42. So the square root of 42 is what we have so far. Then I can pull out 2 pairs of x's. So that gives me an x squared, because when you pull these x's out, you're going to multiply them. So x times x gives me that x squared. Then I have that lonely x left in there, and then that y didn't have anything to pair it with, so that's going to stay the same. So our final answer is 2x squared onto the square root of 42xy. Okay. Now we're going to look at number 62. This problem is a little tricky. Number 62 says I've got the cubed root of 7 over x squared. So this is another problem where we have the cubed root of a number, and we need to first break down the cubed root sign to be over the numerator and then separately over the denominator. So I'm going to bring my colors out again. So I have the cubed root and I have an x times x because x times x is x squared. So I just rewrote my x's out. So I need 3 of a number to release it from the radical. I have 2 numbers, so I need 1 more for it to be released. So I'm going to multiply by the cubed root of x on this side and the same in my numerator, which will give me the cubed root of 7x over the cubed root of x to the 3rd power. Then I have the cubed root of 7x over x. And the reason is because the cubed root of x to the 3rd is represented right here. Okay, we need 3 of a number to release it. So since I have those 3, they all come out as just that 1x. Remember, these cannot be simplified because that x is under the radical. They both have to be outside of the radical in order to release them. Okay. So now we're going to look at number 64. 64 says I have 5 over the cubed root of 3a. So I'm going to go ahead and draw out what we have in blue. We start off with the cubed root of 3 and a. I'm going to leave a little bit of space. So I need, per my index, I need 3 of a number to release it from the radical. So I have 1 3. So that means I need 2 more 3s to be able to release it. So I'm going to multiply by 1, 2 more 3s. Then I have 1a, so I need 2 more a's to release them from the radical. Remember, the whole goal in this is to get rid of that radical that is in the denominator. So I need to multiply my denominator by everything that is written in this pink color. So 3 times 3 gives me 9. A times a gives me a squared. So I'm going to multiply my numerator and my denominator by 9a squared by the cubed root of 9a squared. Okay. So when I multiply my numerators, I'm going to have 5 onto the cubed root of 9a squared. Remember, you can't multiply the 5 times the 9 because that 5 is outside of the radical and the 9 is inside the radical. Sorry, I forgot to switch back to my pencil, so we're just going to continue in pink. Then 9 and 3 give me 27. And then a times a squared is a to the 3rd power, or a cubed. Then I'm going to rewrite my 5 onto the cubed root of 9a squared over Let's look back at what we did here. We now have 27, which breaks down to be 3 3s. So I can pull out one set of 3s as 1. Same thing with my A's. I can pull them all out as just 1. Now that nothing else will simplify, I can go ahead and be finished. You know you're finished once you have gotten that radical out of the denominator and nothing else will simplify in your numerator. So number 66, we are also working with a cubed root problem. Number 66 says I have the cubed root of 5 over 7w squared. I'm going to break this apart to be the cubed root of 5 over the cubed root of 7w squared. So I'm going to write down what I have in blue. I have 1 7 there, and I've got 2 w's here. So I need 3 of a number to release it from the radical. I have 1 7. I need 2 more. I have 2 w's. I need 1 more. Remember, you need 3 of something. So that gives us 3 7s and then 3 w's. So I'm going to multiply by that 49 and then that w. So I have my cubed root of 49w times my denominator, and again by my numerator. So I now have the cubed root of 245w over the cubed root of 343w to the 3rd power. Now, I didn't really have to multiply the 7 times the 49 because I knew I would end up breaking it apart anyway to be 3 7s, which will end up giving me a 7 out in my denominator, and then my 3 w's, which come out as just 1 w. So remember, you only have to look at this chart that you made right here to see what's going to come out if you don't want to multiply numbers like 7 and 49. We know we cannot break apart this 245. We can use a little bit of sense here and say, okay, I just multiplied 5 times 49 to get 245. Well, 5 is a prime number. 49 breaks down to be 2 prime numbers, which are 7 and 7. We need 3 of a number to release it. So that means that the only numbers it will break down to be are 5, 7, and 7. So we know that since we can't simplify any of this, we are now finished. Now on to number 68. 68 says I've got the cubed root of 2 over the cubed root of 9m squared. So I'm going to write down what I have in blue and what I need in pink. So I have the cubed root of 3 times 3 times m times m. I got 3 times 3 because 9 breaks down to be 3 and 3. And m squared, you can break that down just to be an m times m. So I need one more 3, and I need one more m. So I'm going to multiply everything by the cubed root of 3m. So I now have the cubed root of 6m because 2 times 3 gives me 6 over the cubed root of 27m to the third power. The cubed root of 6m does not simplify, so we leave it the same. And then the cubed root of 27 is 3. The cubed root of m to the third is m. We are now finished. Now we're going to move on to the final problem in this section, which is number 70. Number 70 says I have the cubed root of w to the 7th over z to the 10th. My z's look a little funky. I do it so they don't look like 2's. So I'm going to break this up to be the cubed root of w to the 7 over the cubed root of z to the 10. So I'm going to write down what I have in blue and what I need in pink. So I have 10 z's. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 z's there. So let's look and see what we need. I'm going to circle these in groups of 3 because I need 3 of something to release it from the radical. So here I have one group. I have another group here. I have another group here. And then I have one lonely z left over. So I need to multiply here by 2 additional z's because that would give this z the 2 additional ones that it needs. So I'm going to multiply by the cubed root of z squared so I now have the cubed root of w to the 7 z squared over the cubed root of z to the 12. Well, I know what this cubed root of z to the 12 is going to give me because based on this little diagram we just showed, I can take out 1, 2, 3, 4. I apologize if you just heard my cat meow. So I'm going to have 4 z's come out. So that gives me a z to the 4th. And then my w's. I have 7 w's. I've just written W 7 times. And I can pull out one set here, one set here, which means that a W squared will come out, and then I'm left with that last W inside, and then Z squared stays inside. Another trick you can learn is that you can divide your exponents by your index. So 3 goes into 7 2 times evenly. So that's that 2 that comes out. So the remainder of that would be 1. So that's why 1 stayed inside. 3 went into 12 4 times, so that's why 4 came out. So if you looked at the beginning, when we had the cubed root of z to the 10, well, 3 goes into 10 3 times evenly, which notice how we had these 3 groups of z's, and then we had 1 z left over. That's how we could have done that mentally. So we are now done. We have simplified everything that can be simplified, so we are left with w squared onto the cubed root of wz squared, and that is over z to the 4th. Now we are going to move on to section 7.3. And then that way you can just load it, and you can maybe clean out the hoses in the bathroom or something. With the door shut, maybe? Because then it would sound probably really funny on the video. again, okay? We are now working in section 7.3. This is on page 585 of your textbook, and it goes over numbers 68 through 76 even. Numbers 68 through 72 even should just be review problems from what we just did in section 7.2 at the beginning of this lesson. I recommend trying to pause this video and working these problems yourselves, then checking your answers and pressing play on the video to see how well you did. Then you can compare your answers and see where you went wrong or see that you did a great job. So I'll give you a moment to pause the video. Okay, hopefully you got these problems correct. I'm going to go over every single problem just to make sure y'all don't have any questions. So we have the square root of 3. Remember, the whole goal of this is to get rid of that radical that is in the denominator. So I only need one more 3 to release it, so I'm going to multiply by the square root of 3 in our numerator and our denominator. That will give us the square root of 15 over the square root of 9, which means we have the square root of 15 over 3. We cannot divide that 3 into that 15 because the 15 is under the radical and the 3 is not. You must have both numbers outside of the radical in order to release them, or in order to simplify them. Okay, the next problem was number 70. We had the square root of 5x over the square root of 6y. And again, this is number 70. So what we're going to do is multiply by the square root of 6y in our numerator and in our denominator. That will give us the square root of 30xy over the square root of 36y squared. 30 will not break down because we had a number 5 times 6 to get 30. 5 is a prime number. 6 breaks down to be a 2 times 3, which are both prime numbers. So there are no two numbers that we can pull out to release from that radical. So we are left with a 30xy in our numerator, and then the 36, the square root of that is 6, and the square root of y squared is just y. So we are done there. Now let's look at number 72. This is the last problem that was a review. So number 72 says I have 2 over the cubed root of 9. So I'm going to write what I have in blue and what I need in pink. So I have the cubed root of 3 times 3 because 9 breaks down to be a 3 and a 3. So I need one additional 3 to release it from the radical. So I'm going to multiply my numerator and my denominator by the cubed root of 3. I now have 2 onto the cubed root of 3. Remember, you cannot multiply that 2 and that 3 because the 2 is outside of the radical and the 3 is inside the radical. Over the cubed root of 27. Then we can break down the cubed root of 27 to be 3. That concludes the review from the last section. Now I have number 74. Number 74 and 76 are very different problems than what you are used to. Number 74 says I have 2 divided by 3 minus the square root of 2. So in this problem, you would think let's multiply by the square root of 2. But if we had done so, we would have multiplied each term by the square root of 2, which would have gotten rid of the radical in this term, but then we would have had 3 square roots of 2 over here. So that doesn't necessarily help. But what we can do is remember what happens when we multiply two binomials. Let's say x plus 2, x minus 2. All right, these binomials are called conjugates. They are called conjugates of each other. A conjugate is when you have the same exact binomial. All right, so the same thing inside of these sets of parentheses, except you always have a plus sign in one of them and a minus sign in the other. It does not matter which one you write first. Now let's see what happens when we multiply those. X times x gives me x squared. X times negative 2 is negative 2x. Then I have 2 times x, which is 2x. 2 times negative 2, which is negative 4. You will notice that these two terms are going to cancel out. So I'm now left with x squared minus 4. You will notice that this will help us in solving number 74. Remember, the whole goal is to get rid of that radical in the denominator. So what I'm going to do is multiply by the conjugate of 3 minus the square root of 2. We will do that by multiplying by 3 plus the square root of 2. So to multiply these, we are going to have to distribute the 2 into that set of the parentheses. So 2 times 3 is 6. 2 times the square root of 2 is 2 square roots of 2. And then you are going to distribute this denominator. You do that by multiplying 3 times each term in this set of parentheses and negative square roots of 2 times each term in this set of parentheses. I am going to slow down my speaking while describing this to ensure that there is no confusion and you can keep up. So 3 times 3 gives me 9. 3 times the square root of 2 is 3 square roots of 2. Now we are done with this 3. Now I'm going to multiply by the negative square root of 2 times each term inside of here. So the negative square root of 2 times 3 is negative 3 square root of 2. And then I'm going to multiply the negative square root of 2 times that square root of 2, which gives me negative square root of 4. You will notice now, same thing will happen in this set of parentheses, that they will cancel out. You can conclude from this that anytime you multiply two binomials together that are conjugates, your middle two terms will cancel out. So we now have 6 plus 2 square roots of 2 over 9 minus 2. I got that because I brought my 9 over here. My middle terms canceled out. And when I subtracted the square root of 4, I said, okay, well, the square root of 4 is 2, so that would mean minus 2. So now I have 6 plus 2 onto the square root of 2 over 7, because 9 minus 2 is 7. Our radical is out of the denominator, so we are finished. Now we will move on to our last problem on rationalizing the denominator. That is number 76. Number 76 says I have 20 over 4 plus the square root of 6. So I'm going to multiply by the conjugate of 4 plus the square root of 6, which is 4 minus the square root of 6. What I do to the denominator, I have to do to that numerator. So that will give me 20 times 4 is 80. 20 times negative square roots of 6 is negative 20 square root of 6 over. Now I'm going to multiply my 4 times everything in this parentheses and my square root of 6 times everything in this parentheses. So 4 times 4 is 16. 4 times negative square roots of 6 is negative 4 square root of 6. Done with that 4. I've multiplied it by everything. Now I'm going to multiply the square root of 6 times 4, which is 4 square root of 6. Then I'm going to multiply the square root of 6 times negative square root of 6, which is negative square root of 36. Now I'm going to simplify. I'm going to bring my 80 minus 20 square root of 6 over. And you will notice in your denominator that your middle terms will cancel out. So I'm left with 16 minus 6. Oops, and I see I forgot my 0 in the 80. Be careful about that. So I'm left with 16 minus 6. I brought my 16 over here. My two middle terms canceled, and my square root of 36 breaks down just to be 6. Now I'm going to subtract 16 from minus 6. So I'm going to rewrite my 80 minus 20 square root of 6 over 10. Okay? So now I can simplify. I'm going to show you something that will end up explaining why we can do what we're about to do. So if you were to add 1 over 7 plus 3 over 7, we would end up doing 1 plus 3 over 7, because when you add fractions, you combine your numerators to get 1 plus 3 over here, and you keep that same denominator. So our answer for that problem would be 4 over 7. What we're going to do is take it from this step back to here in this problem. So we're going to put our 80 over the denominator of 10, and then our 20 square root of 6 over that denominator of 10 as well. Now we can simplify the 10 into 80 to be 8, and then the 10 into 20 to get 2. So we now have 8 minus 2 onto the square root of 6. We have finished. We cannot combine these two terms because they do not have the square root of 6 on both of them. So we are now finished. I hope this lesson has helped you on rationalizing the denominator. Good luck.